in calculating the integral of x to the fourth minus 2x squared plus 4x plus 1 over x cubed minus x squared minus x plus 1 dx. First, we apply long division because the degree of the denominator, so if you write this as the integral of px divided by qx for simplicity, the degree of qx is equal to 3, and it is less than the degree of the numerator p of x, which is 4. So we have to apply long division first. In applying the method of long division, you have the numerator x to the fourth minus 2x squared plus 4x plus 1, and then you have your denominator as x cubed minus x squared minus x plus 1. So if you multiply the denominator by x and do the subtraction, you can get rid of x to the fourth. So let us begin. We're going to multiply this guy by x first. So basically, you're distributing x into the denominator, and then you subtract that from the numerator. So you end up with negative x to the fourth plus x cubed plus x squared minus x. So now you add these together. As you can see, you can get rid of x to the fourth and x to the fourth because they are opposite of each other. You have to copy down x cubed, and then if you combine these two, x squared and negative 2x squared, you end up with negative x squared. And when you combine 4x and negative x, you get 3x plus 1. We are not done with the long division yet, because the degree of the remainder is the same as the degree of the denominator. So if you just multiply the denominator by 1 and subtract it from the remainder, you get the following. So you have now x 1 times x cubed, 1 times x squared, 1 times x, 1 times 1 subtracted from the rest of the terms. So here you have minus x cubed plus x squared plus x minus 1. So you can get rid of x cubed and negative x cubed. You can get rid of x squared, negative x squared. You end up with 4x, and this is just 0. So this is your remainder. So your integral can be written this way. Let me just copy this guy down. Can be written as the integral of x plus 1 plus the integral of 4x divided by the denominator, which is x cubed minus x squared minus x plus 1 dx. The very first integral is easy to calculate, but for the second integral, we're going to use the method of partial fractions. For the method of partial fractions, let's try our best to simplify this integral. So this is an easy integral. But for this integral, we're going to use partial fractions. So in applying the method of partial fractions, first of all, factor out the denominator. So you can categorize this to cases that help you to find the integral a little bit easier. X cubed minus x squared minus x plus 1 can be factored into, between these two, factor x squared. So you're left with x minus 1. Between these two, factor out negative sign or -1, you're left with x minus 1. Now between these two, you can factor out x minus 1. So this can be written as x minus 1 times x squared minus 1. From algebra, remember that if you have a squared minus b squared, this can be written as a minus b times a plus b. So x squared minus 1 can be written as x minus 1 times x plus 1. So x cubed minus x squared minus x plus 1 is now x plus 1 times x minus 1 to the second power. What's the meaning of that? It means that this linear term is repeated. Linear term x minus 1 is repeated twice. So this is your case 2 in partial fractions. In case 2 of partial fractions, when you have px divided by qx, and qx is linear expression multiplied twice, 3 times, 4 times by itself, this can be written as px over qx can be written as a1 divided by the smallest power of this linear expression, which is 1, plus a2 divided by ax plus b to the second, plus ar divided by ax plus b to power r. But let us go back here. For our fraction, 4x divided by, let me copy this guy down. This can be written as 4x divided by x plus 1 times x minus 1 to the second. What should we do with x plus 1? For x plus 1, just use b divided by x plus 1. And for the rest of them, use a1 and a2. Plus a1 divided by x minus 1 plus a2 divided by x minus 1 to the second. Now take common denominator between these. Which is x minus 1 to the second times x plus 1, and set the numerators equal to each other. So on the left-hand side, you have 4x. On the right-hand side, you have b times x minus 1 to the second plus a1 times x plus 1 times x minus 1, and finally plus a2 times x plus 1. Let us use our shortcut. Set x to be equal to 1. So 4 becomes 0 plus 0 plus 2a2. So a2 is equal to 2. Set x equals to -1. -4 becomes b times -2 to power 2 plus 0 plus 0. So b is equal to -1. But what is a1? To find a1, set x to be 0. Simplest number possible. 0 is equal to b times -1 to power 2 plus a1 times 1 times -1 plus a2 times 1. You have the values for a2 and b, just substitute them. b is -1 times 1, which is -1, negative a1, and a2 is 2 plus 2. So a1 is equal to 1. Okay, perfect. So let us take this guy and find the integral. We found b, a1, and a2. The integral of 4x dx divided by x plus 1 times x minus 1 to the second is equal to, I lost it, okay, b, which is equal to -1, a1 is 1, and a2 is 2. So let's take this integral as well, which in turn is equal to negative ln of absolute value of x plus 1 plus ln of absolute value of x minus 1. And here you have -2, 1 divided by x minus 1 plus c. We need to add that to the integral of the whole rational expression that we had. Let's copy this guy down here. So this integral is equal to x squared over 2 plus x minus ln of absolute value of x plus 1 plus ln of absolute value of x minus 1 minus 2 divided by x minus 1 plus c. For these two, you can apply algebra, combine these together, because you have ln of a minus ln of b, which is ln of a divided by b. So you get x squared divided by 2. And here you have plus x minus 2 over x minus 1 plus ln of absolute value of x minus 1 divided by x plus 1 plus constant of integration.